fundamental theorem of calculus. This is like day 3 of the fundamental theorem of calculus part 1, because there's sort of 2 parts, both the fundamental theorem of calculus. Part 1, day 3.
We need to update the...
Yeah. We'll start part 2 on Wednesday. But basically, the fundamental theorem of calculus part 1 is the integral of a derivative. Well, you tell me, what's the integral of a derivative?
plus c.
Right. The antiderivative of the derivative cancel each other out, but you need to include plus c. Unless there is limits on there. So let's say from a to b. The antiderivative from a to b of the derivative. So what would... It's going to be something similar. The antiderivative from a to b of the derivative.
F of
Yeah, so it's definitely f of something. And instead of an indefinite, that's what the first one is called.
F of b minus f of a?
Top minus bottom. F of b minus f of a. That's called a definite integral. And the definite integral also tells us something about the graph. So it doesn't really work if you don't have limits, but if you're looking from a to b, then this definite integral, do you remember what it represents on the graph? That antiderivative is also the area under, in this case, f prime from a to b. So that symbol, you always have to remember the symbol means 2 things. Antiderivative, but also area. And depending on the problem, sometimes it's easier to work like it's an area problem, like if it's a square or a circle or a triangle. Sometimes you have to work it as an antiderivative problem if the area would be a weird shape, and then you would have to do the antiderivative. Okay, so that's the fundamental theorem of calculus part 1 in a nutshell. Now let's do some problems that remind us or review some of that stuff. Antiderivative of x squared plus 1 over x squared, that's x cubed plus 1 over x squared dx. Antiderivative of x cubed plus 1 over x squared dx. Antiderivative. Does this represent an area or not?
Yes. Yes.
No. Why not?
Because it doesn't have a and b.
It doesn't have a and b. So you wouldn't know, like, well, where am I looking? I don't know. So you can't think of this one as an area because it doesn't have limits on there. So we're going to have to do it. We're going to have to take the antiderivative of what's inside there. Now, there is no magic quotient rule for antiderivatives, so we've got to algebra our way out of this thing. X cubed over x squared would be x. 1 over x squared. I could write it as 1 over x squared, but I can't use the power rule like that, so I'm just going to change it to x to the negative 2. Right, now I'm going to press pause and let you see if you can take the antiderivative of both of those things. Watching at home or re-watching the video, press pause and copy the table down. Antiderivative of the derivative gets us back to f. There are no limits, so just plus c. There's nothing to use the table in part A. Part B, the antiderivative of f prime is f, but at 10 minus at 2, and then we use the table to find those. And then part C, somebody tell me what's one thing that's maybe weird or different about this one.
Double prime.
Okay, the double prime thing. Okay?
7 to 5, not 5 to 7.
7 to 5 and 5 to 7. That's a little bit weird. So which one do we want to handle first? Do you remember there's a way to fix the 7 to 5 thing if you don't like that?
Negative 5 to 7.
You can switch them. If that feels out of order, and it should feel out of order, you can switch them and make it negative 5 to 7. Now, the good news is if it doesn't bother you, you can still work this problem, and you're just going to do the top minus the bottom. It's going to be the 5 first minus the 7. If you switch it, it's going to be at 7 minus at 5, but there's a negative out front. So there's the same thing, and some people will switch it because they feel like it needs to go low to high. Other people are like, what do I care? I'll just plug in 5 minus plug in 7. Same thing either way. All right, I need the antiderivative,
Second puberty?
Yes, the antiderivative of the second derivative. What would that be? The first derivative. I'm undoing one of the derivatives to get back to the first derivative. And I have limits, so 7 minus 5. And that negative sign needs to be out front. So I need to be super careful with all my negatives here. So I'll plug in 7 minus plug in 5 to the first derivative. So I have that. So f prime at 7 would be negative 1. F prime at 5 would be 2. And then there's a negative sign out front. So negative, well, that's a safe stop, by the way. But negative 3 would equal 3. Let's go a little bit crazy with one here. Let's go from 2 to 5. 3f double prime of x plus 2f prime of x minus 7 dx. So the antiderivative from 2 to 5 of 3f double prime plus 2f prime minus 7 dx. Okay, so a lot going on, but one thing at a time. What's the antiderivative of the second derivative? The first derivative. So 3f prime of x, and then I'm just going to put the 2 to 5 right there. I guess I could put it at the very end, but What about the antiderivative of the first derivative? That would be the original, f of x, again from 2 to 5. Now this is where we throw people off because we have to kind of switch our brain from just thinking antiderivatives of derivatives back and forth to an actual number. Like, what's the antiderivative of 7?
7x, negative 7x.
Negative 7x. Again from 2 to 5. So a little bit weird, but break it into pieces. Hopefully not too bad. So 3 times, well, I guess we'll show our work here. F prime of 5 minus F prime of 2 plus 2 times F of 5 minus F of 2 minus 7 times 5 minus 7 times 2. Yeah, the antiderivative of the second is first, the antiderivative of the derivative is the original, and the antiderivative of 7 is 7x. Is this a safe stop? Do you know? I mean, it's not wrong, but is it a safe stop? You don't know yet. That's okay. It's not a safe stop. You can't leave function notation. You have to plug them in.
Yeah.
So, well, I guess this in part would be fine. But f prime of 5, f prime of 2, you have to plug those in. So we need to figure out what those are. F prime of 5 is 2. F prime of 2 is 4. F of 5 is negative 3. F of 2 is 1. And then, why even bother? Let's leave it alone. That now is a safe stop. All right, now it's just ready for some computation. We don't really want to do that. Again, unless it's multiple choice, and then we have to figure out which one it is. But left to our own, we would stop there. Let's do one more using that table. Let's estimate the second derivative at 6. Estimate the second derivative at 6. So we look back at the table and we're like, well, we don't have 6, nor do we have the second derivative. So what in the world? How can I estimate? Okay, so if you're thinking rectangles, that would be how we estimate area. Okay, so that could have been another problem I did off this table, is a Riemann sum kind of thing. So f prime is the change in f, or excuse me, f double prime is the change in f prime over change in x. I mean, it's approximated by that. This is an instant rate of change, and this is an average rate of change. So I can do the average rate of change of f prime and estimate, or use that to estimate the instantaneous rate of change. So if I wanted to do at 6, which values should we use, right? Average rate of change is just algebra slope, algebra slop. So yeah, let's use 5 and 7. And that'll be close enough. So f prime of 7 minus f prime of 5 all over 7 minus 5. So the rate of change in f prime would get us f double prime. So f prime of 7 is negative 1. F prime of 5 is 2. 7 minus 5 is 2. So negative 3/2. So the average slope of f prime is f double prime, or is estimated. All right, that was a review question. That's not really fundamental theorem of calculus stuff. Let's get out the worksheet packet and do some of those together. So today's assignment is worksheet 2, but let's go over some together. And by the way, you will need a calculator, so go grab one if you need one.
May I borrow one?
Yes, they're back there.